Hey guys, Mr. Wilson here. Today we're going to talk about the angle addition postulate. Okay. At the end of this video, you should be able to use the angle addition postulate to find missing angle measures. Okay. An angle, and our symbol that we use with that is this thing here. Okay. Okay. Kind of flat on the bottom. Is formed by two rays with the same endpoint. The endpoint is called the vertex. Okay, so if we look at this angle, it is formed by the rays BT and BQ. Remember, when you name a ray, you always name it with the endpoint and then to the direction of the other points. Okay, the vertex is B. Notice that that is the endpoint of the rays that make it up. Now we can name this angle in a bunch of different ways, and we'll look at it a little bit more as we go through the year. So if an angle is easily identified, sometimes we just call it by its vertex. We can say angle B. Okay, notice we still use that angle symbol. We could, because they have this 1 indicated in here, call it angle 1. A lot of times they'll number the angles for us just for the clarity. Okay, but we can also name it based on how we would draw it without picking up our pencil. Okay, so if I was going to draw this angle without picking up my pencil, I go from T to B to Q. So I could call it angle TBQ. Okay, I could also name it from Q to B to T. So I could call it angle QBT. Okay, notice that the vertex is always in the middle of that. Oh. Alright. So, in this example, just naming the angle, okay, asks us to name angle 1 in another way. So angle 1, here on this side, well, I can name angle 1. Now first, I'll tell you how I would not name angle 1. I will not name angle 1 B. Okay? And I won't call it B because if I call it B, what that does is it makes whoever's reading it not know if I'm talking about angle 1 or angle 2. So notice that B is the vertex of both of these angles. Okay, so I'm going to call it angle CBA. Okay. Angle 2. In another way, I'm going to call that angle DBC. Okay. It says name angle S in another way. I am sure that is a misprint. I don't see angle S anywhere. Okay. Alright. 4 says how many angles are in this figure. Okay. So we have angle 2, we have angle 1, but we also have ABD. Okay, ABD is also an angle here. So I actually have 3 angles in this picture. Okay, ABC, CBD, and also ABD. Alright, so let's talk about classifying angles really quick. This should be a review from your middle school days because you've done this, I feel like, every year for a while. But an acute angle has the following angle measures. An acute angle is anything less than 90 degrees. Okay, a right angle equals 90 degrees. Measure of the angle is less than 90. The measure of the angle is equal to 90. Okay, an obtuse angle, the measure of the angle is greater than 90 degrees. And then a straight angle, the measure of the angle is equal to 180 degrees. The highest number it can be is 180 degrees. It can never be 0. Okay, remember this can't be 0. And like I said, this can't be greater than 100 degrees. Or, sorry, can't be more than 180. So now let's talk about the angle addition postulate, and this is very similar to the segment addition postulate. Scenario 1 says if B is in the interior of angle AOC, just like our diagram shows here, then we can say that same part plus part equals whole. AOC, angle AOC, angle AOB plus angle BOC equals angle AOC. So again, part plus part equals whole. And then the second scenario is just shown because if we have a straight angle, we can't call where B is going to be interior. So just by definition, we just have to give it a different scenario. Okay, so for straight angle AOC, which since AOC is a straight line, straight angle is 180 degrees, we can say the same thing, that angle AOB plus angle BOC, same thing, AOB, BOC, equals 180 degrees, or angle AOC. Okay. In both cases, again, you can think of this as part plus part equals whole. So now we're going to use the figure below to answer these following questions. They want us to find the measure of angle CBA. So they want us to find the measure of angle CBA. They tell us that DBC is 24 degrees, and then they tell us that ABD is 83 degrees. So ABD is 83 degrees. Okay. So how are we going to find the measure of CBA? Well, I know that part plus part equals whole. So 24 plus, should have used a different color out, and I'll have a different color out. 24 plus x, and in this case x will stand for this angle that we're looking for, equals 83. Part plus part equals whole. Okay, and so now I can just do some algebra to figure out what that will be. I'll subtract 24 from both sides, and when I do that, that will give me 59. And so then I can find out that x has to be 59. X stood for angle CBA. So the measure of angle CBA was 59 degrees. Asks us to find the value of x and show the equation. I would like you to please do that and bring it in to class, complete it for me. Thank you. Okay, and make sure as you're doing that, guys, that you wrong color, that you find the value of x, write the equation, all that stuff, but then also classify those angles. Okay, obtuse, acute, right, or straight. Alright, and then our final example we'll do all together. It says find the measure of each angle. They tell us that BOC is 12x plus 5. They tell us that AOD, that whole thing is 105. Okay. Okay, and so I see that they didn't get, that this didn't print out, so I'm going to make sure I add this on here. We need to make sure that we know what this angle is, angle AOB. Okay, we're just going to say that that angle is 2x. Why not? Okay. Alright, so we're going to say that angle is 2x. Okay, so now this will help us with our information because we see that this angle AOB is 2x. Okay, and this actually tells us what this angle is as well, 2x. So notice that the markings on the angles, those represent congruent angles. Okay, just like the dashes represent congruent line segments. Okay, so now we're going to use that information because now I know that 12x plus 5, BOC, plus the other parts of this angle, 2x plus 2x, should equal 105. And so we get down to it, we get 16x plus 5 equals 105. Subtract 5 from both sides, so 16x equals 100. Divide by 16. Okay, and x will equal whatever that is. 6.25. Or 6 1/4 either way. Okay, so 6.25. Okay, and now we can use that information to find out what BOC is and what BOD is and what AOC is. And we can just do that by plugging it in. We can say 12 times 6.25 plus 5. Which would be 80 for BOC. And then 2 times 6.5 for both of these will be 12 and a half. 12.5 and 12.5 BOD, because BOD is talking about these two. So it'll be BOC, which was 80, and then 12.5, which is the 2x, which will give us 92.5. And then AOC will be the same thing because we're again adding 12.5 plus 80. Alright, so there you have it. Angle addition postulate, the same as the segment addition postulate, really, except now we're talking about